Hello my friends, welcome to this new practical activity on polynomial regression. This time we're going to learn how to build together a nonlinear regression model which will allow us to tackle a problem with a nonlinear dataset, meaning a dataset with nonlinear relationships on which therefore a multipolinear regression model would not be relevant. Alright, so as usual, I just want to make sure here that everyone is on the same page. So right before this tutorial, I gave you the link of this folder. So make sure to connect to that link and you'll be inside this page just like me, ready to start this new polynomial regression model. And now we're all going to go into part 2 regression. We're still learning on how to predict a continuous numerical value, and this time we're going to go to section 6, polynomial regression, to learn how to build indeed this nonlinear regression model. Alright, and as usual we're going to start with Python, inside which you will find two files, polynomialregression.ipynb, which is of course your Python implementation, which you can open either in Google Colab or Jupyter Notebook, and the dataset called position salaries. Alright, so as usual we're going to start by describing the dataset. Once again, I'd like to remind that this is a simple dataset, and that's only, because we're starting with our journey of machine learning. So right now I want to work on simple datasets so that you can focus on how to build the models themselves without being too overwhelmed by a complex dataset. But no worries, the further we progress in this course, the more we will work with real-world and complex datasets. You will see at the end we will work with datasets with many more observations and more complexities. Alright, so no worries about this, we will get there little by little. So, what is this dataset about? Well, let's imagine the following scenario. Let's imagine that we are actually an HR department and that we want to hire someone. And we actually found someone that seems to be a great fit for the job. So we would like to offer this person a position in our company. And so this person says yes, but at the end of the interview process comes the inevitable question, what is your salary expectation? And let's say that this person is, very well advanced in its career, and therefore that person is asking for $160,000 per year. And then also as HR negotiators, we ask this person, why are you expecting such a high salary? And this person replies, well, that's because that's what I earned in my previous company. That was my salary in my previous company. I earned $160,000 per year, so I'm expecting at least $160,000 per year in your company. Is that the truth or is that a bluff? Well, that's exactly what we're going to figure out thanks to our polynomial regression model. We're going to build a polynomial regression model to predict the previous salary of this candidate. So how are we going to do this? Well, of course, in order to make such a prediction, we need data. And that's exactly the data we collected here. So what is this data and how did we collect it? This data is actually the different salaries of the previous company for the different positions from business analyst to CEO. And now how did we collect such data? Well, there are many websites online which actually display the different salaries of the different positions in companies. I can give you an example like Glassdoor. Well, let's say that we did this, and that's how we collected all this data containing all the salaries for the different positions of this previous company for which this person worked. Okay, so we have this data, and now we need to know obviously which position this person had within this previous company. Well, that's easy. Let's say we went to LinkedIn and we checked out the profile of this person, and we actually saw that this person was actually a region manager. Okay, however, on the LinkedIn we also see something else. It turns out that this person actually has been a region manager for quite a while, like let's say 2 years. And therefore, the salary of this person should not exactly be $150,000, as we can see on this dataset. But instead, it should be somewhere between $150,000, the salary of position number 6, and $200,000, the salary of position number 7. So in order to extrapolate, we're going to suppose that this person has a position in between 6 and 7, and we'll consider this position to be 6.5, so that then we can actually deploy our model, after training it, of course, on the position level 6.5 so that we can get the predicted salary of such a position level. And we will compare this predicted salary to the salary expected by this person to see if indeed there is truth or bluff. Alright, so that's the strategy. It's basically going to be in 4 steps. First step, data preprocessing. Second step, we will build the polynomial regression model. Third step, we will train it to understand the correlations between the position levels and the salaries. And fourth step, we will make that prediction. Now, time to brainstorm together on what are going to be the first steps, within that data preprocessing phase. Well, of course, we'll start by importing the libraries, then we will import this data set. But then, do you think we actually need to split this data set into the training set and the test set? Well, here, exceptionally, because we have very few observations, we actually won't split the data set into a training set and a test set, because what we want to get directly is actually that prediction of the position level between 6 and 7. We will say 6.5. So we actually need to get the maximum data we can, and that's why we're going to take everything to train our polynomial regression model. So exceptionally, we won't apply that third sub-step of the data preprocessing phase. And then, obviously, we won't have to use any other tools of the data preprocessing toolkits, like taking care of missing data or encoding categorical data, simply because here we will just train our polynomial regression model on these 2 columns, level and salary, because indeed this column is just redundant with this one, right? It's as if the encoding was done simply on the spreadsheet. So we will actually not include this column. We will train our polynomial regression model with this column as the column of features, the matrix of features, even if there is only one feature, and this column as the dependent variable vector. All right, are you ready? Let's do this. Let's build our polynomial regression model. So we're going to open our IPYNB file or Python file. You have the choice to open it with either Google Colaboratory or Jupyter Notebook. And for Google Colaboratory lovers, let's open this right now and let's see what we have in our notebook. Laying out notebook, and there we go. So I remind that this notebook is in read-only mode, and since we, as usual, want to re-implement this from scratch, we're going to go to File here to create a copy by saving a copy in Drive. And as you see, it is creating a copy in which we will be able to re-implement the whole model from scratch. And there we go. All right, so now, as usual, we're going to delete all the code cells so that we can re-implement this from scratch. Make sure to only delete the code cells and not the text cells so that we can see the structure. You're starting to know the story now. And lastly, this one. Perfect. All right, so this is the whole structure of this implementation. Let's have a look. I already brainstormed with you on what would be the first steps, but I really want you to clearly see the whole structure, okay? So we're going to start by importing the libraries, then importing the dataset. Then, as I told you, we're going to skip the step where we split the dataset into the training set and the test set, simply because we want to leverage the maximum data in order to make our future prediction of the salary for the position level between 6 and 7. So we skip this step, and then we move on directly to first, actually, the training of the linear regression model on the whole dataset. And that's for the simple reason that we want to compare the 2 models, linear regression and polynomial regression, because I want to show you that indeed a polynomial regression model will be much more adapted to this dataset. And you know the reason? That's because the dataset has nonlinear relationships. So in the end, we will actually, as you can see, predict the salary of the position level between 6 and 5 with linear regression and polynomial regression. And you will see that we will get a much better result with polynomial regression. Okay? So after training the linear regression model on the whole dataset, we will train the polynomial regression model on the whole dataset as well. Then we will visualize the linear regression results on the whole dataset again, and then the polynomial regression result. And once again, you will see that indeed the polynomial regression model is much more adapted to this nonlinear dataset than the linear regression model. And finally, we will make our last 2 predictions, predicting a new result with linear regression and predicting a new result with polynomial regression. And at the same time, you will learn how to make a single prediction, because what we've done so far, when making predictions, was to input the whole test set features. We input X test in our predict method, and that returns indeed some predictions of the test set, but you actually still don't know exactly how to predict the result of a single observation. And that's exactly in this practical activity that you will learn it. Okay, so that will be a good new skill to know, and I will of course ask you to try to do it on your own before we do it together. And so there you go, that's the whole structure, and now we're ready to start, and we're gonna tackle this semi-data preprocessing phase in a flashlight, starting by importing the libraries, and thanks to our data preprocessing template. So I'm copying this here, pasting that right here in a new code cell. Then we're going to import the data set using still our data preprocessing template, because indeed we will have only one thing to change, which is of course the name of our data set. No, actually, my mistake, we will have two things to change, and I will explain why right away. So first, let's change that obvious thing, which is the name of the data set. So let's see the name of the data set again, position salaries. All right, so let's do this. I'm going to replace data here by position salaries. Great. And now the second thing I wanted to change is of course the matrix of features X, because remember that this automatically takes all the columns except the last one, but actually here, you know, these two columns are redundant. It's like we already did the label encoding, you know, to encode each of these positions into numerical integers going from 1 to 10. But I wanted to leave that column because it's pretty nice to see the names of the different positions, you know, from business analyst to CEO. So we actually don't want to include this column, and therefore we will start to get the column from the second index, which is index 1, right? Because indexes in Python start from 0. So there you go. We're only going to take that column, and to do so, well, we're going to replace that empty lower bound, which means the first index, by index 1, so that it will indeed take all the columns from the second one, you know, of index 1, up to the last one except the last one. And therefore, it will take all the columns from this one except this one, and therefore just this one. See? Just a simple trick. All right, so now we're all good. This will still take the last column, the dependent variable vector containing all the salaries, so we're all good. And we can move on now to the next step, which will be to train the linear regression model on the whole data set. Great, so would you like to execute this now? Yes, maybe let's do it now so that it's done. So let's click this folder here to be able to upload the file. Right now it is connecting to a runtime to enable file browsing, and in a second, yeah, there we go, we should be able to upload the dataset. All right, so we're gonna go to our machine learning A to Z folder. I always put it on my desktop, then part 2 regression, then section 6 polynomial regression, then Python, and there you go. Let's get and upload our position salaries dataset. That's all good. Now we have it, so now we can run these first two cells. First importing the libraries. Okay, done. And now importing the dataset. And done as well. And now we can move on to the next step, training the linear regression model on the whole dataset. So try to do it on your own, because you now know how to implement the linear regression model. So I trust you will smash this. There is no trap, and this will be a good way to practice again. So as soon as you're ready, well, let's move on together to the next tutorial to build that first linear regression model together, and then the polynomial regression model. And until then, enjoy machine learning.